I'm going to demonstrate SolidFire's integration into CloudStack, what will be version 4.11, which is still in development, and how it integrates with VMware. As we see here, I'm on the Infrastructure tab, and just to give you a little bit of an overview of how my cloud is set up, I have a single zone, single pod, 3 clusters, one of which is a VMware cluster, and I have a few primary storages. Let's take a quick peek at the clusters. I'll click on the View All button. We can see I have a XenServer, KVM, and VMware cluster. The bottom one is the VMware cluster. I'll go ahead and click on that row. And then in the upper right, I'll click on View Hosts. And we can see here I have 2 hosts. If we switch over to my Windows virtual machine, we can see our 2 hosts here as well. Back to the CloudStack GUI, I'll click on the Infrastructure button again, and this time the View All button of primary storage. And what's of most interest to us here is the second row, which I'll go ahead and highlight. This is zone-wide primary storage that's based on the SolidFire storage plugin. It has 2 unique characteristics when compared to traditional primary storages. The first is that it is at the zone level as opposed to the cluster level, which is the more traditional level. The other is that we do not provide to CloudStack for this primary storage a pre-allocated volume. What we're doing is giving CloudStack access to a certain amount of capacity and performance on a SolidFire cluster. And then CloudStack can make use of that through the SolidFire storage plugin when it needs to spin up volumes, create volumes dynamically for VMs that are spun up or for data disks that we create and want to attach to virtual machines. Now let's switch over to the Service Offerings tab and create a compute offering. In the upper right, I'll click on Add Compute Offering. I'll provide a name. Let's go with SolidFire Compute Offering 1, SFCO1, and provide some kind of a description. Maybe I'll just specify in parentheses here the performance I expect out of the virtual disk. So let's say 300 for the minimum IOPS, and the max can be 600. Go 1 CPU core, 200 megahertz rating, 128 megs of RAM, and then we're going to scroll down here and we see the QoS type combo box. I'll click on that and select storage. As soon as I select storage, we'll see a few fields appear below the QoS type field. So here we are. I can fill in my minimum IOPS, which in the description we said were 300, and we'll fill in 600 for the maximum IOPS. Now the hypervisor snapshot reserve field, I am going to fill in 125 for this. And the way this works is, for example, if we spin up a virtual machine that has a 2 gigabyte we would want that backed by a SolidFire volume that's not just 2 gigabytes, but somewhat larger for at least a couple reasons. One is that the virtual disk is going to be placed within a data store, so we have some additional metadata requirements that we have to be able to store on our SolidFire volume in addition to the virtual disk itself. And also, if you wanted to take hypervisor-based snapshots, those delta images are also stored within the data store that's on our SolidFire volume. So what this is saying is we want our SolidFire volume to be 2 gigabytes plus an additional 125% of 2 gigabytes. So we're going to be looking at something between 4 and 5 gigabytes. For the storage tags, this is business as usual. What I'm going to do is, I know I have my primary storage already set up, and it has a storage tag of SF-A, so I just typed in an S. It's located automatically, and I can just hit the Enter button here to select it. And now we're all good. I can just go down to the bottom and hit the OK button. In a moment, we'll have our compute offering that can make use of our SolidFire primary storage. Now let's go and spin up a virtual machine that makes use of that compute offering and see what all takes place. I'll switch over to the Instances tab in the upper right. I'll click on Add Instance. We're going to be building this VM based on a template, so I'll just click Next. I will pick my, it's already selected, my CentOS 5.3 template is already selected for vSphere, so I'll click on Next. I'll select the compute offering that we just created a moment ago and click on Next. We will not pick a disk offering, but we could do this if we wanted to. It's just, I'll keep the demo as streamlined as possible and just demonstrate here the use of a compute offering. And we can go back later and add a data disk onto our virtual machine as step 2 of this particular demo. I'll click on the Next button, Next, Next, and Next. And here I will just provide a name for this virtual machine. Let's go with VM-VS-1, and I'll click on the Launch VM button now. So what's happening here is CloudStack is, in many things are happening, but one of the things that's happening is CloudStack is trying to figure out what kind of primary storage may exist upon which it can place the virtual disk for this virtual machine. It's going to look at the compute offering that we selected. It will see a storage tag is specified. It will go through our list of primary storages. In this case, there is actually only one primary storage that can satisfy the storage tag of our compute offering, so CloudStack will select that primary storage. That's our zone-wide primary storage that's based on the SolidFire storage plugin. Once that's selected, CloudStack will start invoking functionality on that plugin, such as create a volume. And what we will then see, if we switch over to the SolidFire GUI, which I'll do now, and if I refresh this Active Volumes tab, well, we can see right now I already have a single SolidFire volume on my SAN. That's actually in use for my KVM cluster. When I hit refresh here, we should see more information. So here we see we have a new volume, volume ID 20, this CentOS 5.3-X64. This is a SolidFire volume that was created. We put a data store on it, and we copied the template from secondary storage to this particular SolidFire volume. Once that process is complete, we will go ahead and clone this SolidFire volume into a new SolidFire volume that has a data store and a virtual disk, and that virtual disk will be used as the root disk of our virtual machine. So if I hit refresh here, we'll see if we've made additional progress. Looks like we're still in the process of copying this particular template from secondary storage down to primary storage. If I scroll over to Actions, we can view details. Now here it should give us an idea in terms of I/O, what's going on with regards to the volume. And let's see, we'll give it a moment to refresh itself. All right, so we don't really see any I/O going on, which to me indicates if I switch back to the volumes tab, we'll see that this volume is actually done. We're complete with the process of copying the data from secondary storage to primary storage. So I'll click on the volumes tab. And now we are in the process of cloning this particular SolidFire volume to another volume. And once that cloning process has completed, we will see that there is some work to be done on the VMware side in terms of resignaturing the data store that's on our newly cloned volume. So the way VMware data stores work is they're associated with some kind of a unique identifier. And when you clone a volume with a data store from a backend system like our SAN, you're going to have the same data, including the same identifier on the cloned volume. So in addition to actually cloning that volume, CloudStack now needs to talk to vSphere and tell it, here's our new data store. It was cloned from an existing one, so it will have a non-unique identifier that we need to make unique. And so that's part of this process. And perhaps if we switch over to the VMware side, oh yes, we can see here, resignature unresolved VMFS volume. So the process right now is undergoing where we're resignaturing that new data store, which has our virtual disk that will serve as our root disk for our virtual machine. And in a moment, this process will be complete. It takes a little while, probably a couple minutes overall to go through this whole process. So what I'll do is I'll pause the recording and come back in just a moment. Okay, we're back. Our virtual machine has been successfully spun up. If I go and click on the Instances tab, the CloudStack GUI will fill in its IP address. We can switch over to the Quick View column and view the console to see that the virtual machine is in fact booting up. While CloudStack is working on that, let me go and show you the SolidFire GUI and see what's happened in this environment. I'll go ahead and click on the refresh button, and now we can see we have, and I'll highlight it here, not only our SolidFire volume, which contains the template that we copied from secondary storage down to primary storage, but we also have a volume, in this case called root-10, which was cloned from the CentOS 5.3 volume. So if we look at the volume access groups column, called access groups here in the GUI, we can see, and I'll hover over it, our root-10 volume is in a volume access group, which in this case was automatically set up with the two IQNs of our two ESXi hosts. So now both of those ESXi hosts have access to this particular SolidFire volume, which contains a data store, which contains the root disk of our virtual machine. If we see below, the CentOS SolidFire volume is not in an access group. It was while we were in the process of copying the data from secondary storage down to primary storage, but once we finished that process, we took it out of the access group. Have done here, we've spun up a VM that makes use of that template. So what happens there is the SolidFire system will clone that volume into a new volume. And then that new volume is what we use within CloudStack and vSphere. So if I switch over to our vSphere environment, we can see here, I'll highlight it. This I-2-10-VM is our virtual machine that we spun up. We can switch over to its console view. And it's okay, it's great, it's done booting up. So if we do a login here, maybe clear out and then do, let me get rid of that line. We'll do FdiskL we can see we just have a single virtual disk right now, 2 gigabytes. And so that reminds me actually with regards to the hypervisor snapshot reserve. If we look on the SolidFire system, we should see a volume somewhere between 4 and 5 gigabytes. Let's switch back to the SolidFire GUI, and here we are, 4.8 gigabytes. And if we look at the performance characteristics, we can see minimum IOPS at 300, maximum at 600. And this burst is actually calculated by some multiplier that we provided to the SolidFire storage plugin. What it's doing in this case is taking the maximum IOPS, multiplying it by 1.5, and arriving at burst IOPS. So all of this information looks correct. And if we actually take a look at the attributes, we can see here that this SolidFire volume is associated with volume ID 13 within CloudStack, and it tells us the virtual size, which is 2 gigabytes for the virtual disk. Now let's go back to vSphere, and we can take a look at our 2 ESX hosts. Right now we can see down in the details section, we have 1 connected target on this particular host. If I look at the other host, it should be the same. 1 connected target, and then for either of these, if I right-click on the iSCSI software adapter, go into Properties, go into Static Discovery, this is the IQN of the newly created SolidFire volume, which contains our data store, which contains our virtual disk. So this all looks great. I'll close out of that and switch back to the CloudStack GUI. And let's see here if we can go into the console view. So here we are in the console view, and we're seeing the same thing that we saw within the vSphere GUI. Now let's go ahead and take a look at some of the new features that are to be introduced in the 4.11 release. I'm going to switch over to the Storage tab. We should have just a single virtual disk. There it is, root-10. This is the root disk of our virtual machine. Now what I'd like to do is take a snapshot of this. Now traditionally within CloudStack, a volume snapshot is more akin to a backup. What happens traditionally is your virtual disk gets a snapshot taken, and then the read-only virtual disk, which contains essentially the snapshot information, is copied from primary storage to secondary storage. So that data lives on a different storage device, what most people would probably refer to as a backup. What we'd like to do, though, is take a volume snapshot and have that snapshot be very fast and very space efficient. In other words, we need it to happen and be stored on the SolidFire system. So what we do is we go over to the Quick View column, and we can either click on the Take Snapshot button here, or we can click on the row in the table, and we can see we have our details for the particular volume as you'd expect. One of the options up top is to take a snapshot. I'll go ahead and click on this button, and I'll provide a name. Let me do something like ss underscore root-10_1. What we'll do here is I'll click on the OK button, and then we'll switch over to vSphere for a moment. We can see that I did in fact take a VM snapshot, but I'm not going to copy that snapshot from primary to secondary storage. What I'm doing in the background is taking a SolidFire snapshot of our volume, which contains our data store, virtual disk, and the snapshot of that virtual disk. The reason we took a VM snapshot was to acquire a bit of quiescing from the point of view of the file system, of the file system that's on that virtual disk. So later, when we make use of this particular snapshot, we will go to that read-only version of the hypervisor snapshot and leverage that for new volumes that we create within CloudStack that are based on that snapshot. So let me switch over to the SolidFire GUI, or I should say the CloudStack GUI. And if I look under notifications, we can see that the take snapshot was successful. I'll close out of that. And if we look on the SolidFire GUI now, and I haven't refreshed it yet, I'll highlight this particular volume. The row does not yet specify any snapshot. Once I hit the refresh button, we'll see that we do have one snapshot. If I click on it, we can see this is our snapshot. And so, unlike traditional volume snapshots in CloudStack, which are backups of data that was copied from primary storage to secondary storage, this is a SolidFire snapshot of the volume that contained the data store that our virtual disk was on. These are very fast snapshots, very space efficient. And we can use them just like any other volume snapshot within CloudStack, in the sense that we can create templates from them, which those templates do reside on secondary storage, or we can create new CloudStack volumes from these volume snapshots. Okay, let's demonstrate the process now of creating a new CloudStack volume from our volume snapshot. I'll switch back to the CloudStack GUI, go to the Storage tab. In Select View, I'll switch over to Snapshots. We can see we have our snapshot here. And within the Quick View column, I have a few options. I can create a volume, I can create a template, I can revert the volume to a particular snapshot state, to this snapshot state, and of course I can edit the snapshot. And if we want to, I can click on the row within the table and see some of the details of this volume snapshot and perform the same actions above. So here, let's go through the process first of creating a volume from our snapshot. What we'll see here, we'll just provide a name first, vol-1. I'll hit the OK button. What's going to happen is we're going to create a clone on the SolidFire SAN of our snapshot. We're going to clone that snapshot into a new SolidFire volume, and then we'll place that SolidFire volume in the appropriate volume access group so our ESXi hosts have access to it. Now, we can't quite finish the process there because, as noted earlier, we actually have a unique identifier within the data store that needs to be updated. So we have a new volume. We want to make sure that our unique identifier within the data store that's in our new volume is in fact unique. And to do that, we need to issue commands to vSphere to have it create a new universally unique identifier so that we can make use of that data store. And if I switch over to the SolidFire GUI now and go over to its Management tab, we can see, I'll highlight it, we do in fact have a new volume by the name vol-1. It's in the appropriate volume access group. It has the performance requirements that we would expect. If we go over to vSphere, we can see here we're in the process. Perhaps I'll scroll down a bit here. We can see there was some operations that were being taken to make use of this data store within the newly cloned volume. And we're still in the process of running through those operations. So what I'll do here again is pause the video and come back in just a moment when this process has completed. Okay, the process appears to be completed now, so let's go over to the CloudStack GUI and see if it agrees. I'll look at the Notifications tab. create volume was successful. So let me click on the storage tab, and we can see now we have in fact two volumes, the root disk, root-10, and the data disk, which is vol-1. So let's go ahead at this point and attach this data disk to our virtual machine. And I'll click on the OK button here. I just have a single virtual machine up and running in my environment, so it should be the only one in the combo box. I'll click on the OK button. Now I'll switch over here to the SolidFire GUI and hit the refresh button. Actually, I hadn't hit refresh the previous time, but after we created that SolidFire volume based on the volume snapshot, we took it out of the volume access group because the volume was not attached to any virtual machine. And now that we're going back through the process of attaching that virtual disk to a virtual machine, we see within the CloudStack, within the SolidFire GUI, that vol-1 is in fact in a volume access group. So if we switch over to vSphere, we can see here we've successfully, I'll highlight that, we've successfully reconfigured the virtual machine. In this case, we did that because of attaching a new virtual disk. We can see that we have a second connected target on this ESX host, and if I click on the other ESX host, we'll see same information in this particular situation. I'll right-click on our iSCSI software adapter again, click on Properties, and then go over to Static Discovery. And so now we have the IQN not only of the SolidFire volume containing our root disk, but another SolidFire volume which I just highlighted, and this is one containing our data disk. I'll close out of here, and if we go back to the CloudStack GUI over to the Instances tab, I'll go over to Quick View, View Console, and hit Enter to refresh this. I'm going to run FdiskL again. So before we saw that we only had a single device, 2 gigabytes. Now we should see 2, and in fact they should both be 2 gigabytes because the new volume is based off of our original volume. So I'll hit Enter now. Oh, you know what? I have to actually, because VMware Tools is not installed in this particular virtual machine, you actually need to go through the process of either restarting the appropriate service or just restarting the virtual machine to actually see that new device. So let me switch over to Quick View, and I will go ahead and reboot the virtual machine. And in just a moment, I will resume the video and we can see that we have this new device. All right, our virtual machine has rebooted, and I'm going to log in and we'll check on that device, FdiskL. And here we are now. We've got dev SDA, which is our root disk, which we had before, and now we've got dev SDB, which is another device of the same size, which is in this case expected because we did create it based on our root disk. So this all looks very good. Let's switch back to the CloudStack storage tab. So in summary here, we now have 2 virtual disks, each of which resides on its own SolidFire volume with its own performance characteristics. In this case, their performance characteristics happen to be the same. They each have 300 minimum IOPS, 600 maximum IOPS, but those performance characteristics are dedicated for each volume. The one volume cannot impact the performance of the other volume. And through CloudStack, we can actually go ahead and change performance characteristics as well as the size of those virtual disks. Let's switch back to the Snapshots tab, and In this situation, I want to go to the Quick View column and create a new OS template. So let me provide a name. I'm just going to use something simple like T1 and T1 DESC for the description. And I know it's it's CentOS 5.3 64-bit as the OS version. So I'll go ahead and select that. And we're basically done here. We can make it public or do other things, but I'm just going to go ahead and hit the OK button. Now, this process will take a couple minutes, so I will go ahead and pause the video and resume when it's all done. Okay, the process has completed. If we switch over to the Notifications tab and scroll to the bottom, Create Template was successful. I'll switch over to the Templates tab, and we can see we have T1, which is a VMware template. I'll click on T1. We have the information we would normally expect to see, the hypervisor type, the size of the template, the OS type, all that kind of information. I'll switch over to the Zones tab, and we can see that the download was complete and it is in the ready state. I'll click on the zone. We have additional information here. Let's go ahead now and make use of this particular template. I will go over to the Instances tab. In the upper right, I'll click on Add Instance. We'll proceed by using a template, the template that we actually just created. If I switch over to My Templates and select T1, then Next, I'll pick the same compute offering that we used for our previous virtual machine, but of course we wouldn't have to in a real-world situation. It's just I have a limited number of compute offerings that I've created for the purposes of this demo. I'll click on the Next button, and actually while we're at it here, let me click on SFDO1. This is a disk offering in a similar sense to our compute offering, but this is a disk offering that makes use of the same SolidFire storage plugin. So in this case, the one and only zone-wide primary storage that we have, and it will create a data disk using that particular primary storage. I'll click Next, go through Affinity Networking SSH, and provide a name for this virtual machine. Let's use VM-VS-2, and then we'll launch the VM. So this will take a few minutes. In the meanwhile, I'm going to pause the video and resume once the process has completed. The process of spinning up our VM based on our new OS template has completed. If I click on the Instances tab, that'll fill in our IP address. There we are. Let's go to the Quick View column and View Console. I'm just going to exit out of that window and log in. I'm going to clear the screen and then run FdiskL. So what we can see here is we have two devices. The top one, dev SDA, is our root disk at 2 GB. And the bottom one, dev SDB, is our data disk that was based on our disk offering, which was set up at 200 GB. Now if we switch over to the SolidFire GUI, here we are, I'll refresh this view, and we can see here, let me highlight part of this name. That is a new SolidFire volume which contains a copy of our new OS template. So we took the OS template from secondary storage, we copied it to a SolidFire volume, and once that process was done, we cloned that volume into root-11. And we can see root-11 over in the access groups column is in a volume access group, as well as data-11 being in a volume access group. Now, they're in the same volume access group, the one that gives access to our two ESXi hosts. It gives them access to the appropriate SolidFire volumes. So we would expect for volume ID 24, which is the SolidFire volume that contains our new OS template, that it is no longer in an access group. It only was temporarily while we copied the template from secondary storage down to primary storage. If we look over on the farther right, we can see for root-11, it has, as we'd expect, 300 minimum IOPS and 600 maximum IOPS, which was specified by its compute offering. If we look at data 11, which is the top row, it has different performance expectations, 3,000 min, 5,000 max IOPS respectively. That information came from our disk offering. And if I switch back to the CloudStack GUI, scroll to the bottom, service offerings, and then go over to disk offerings, we can see we just have this one disk offering. The description tells us 3,000 minimum, 5,000 maximum IOPS, and 200 gigabytes is specified in a column here further to the right. If we go into the details, by clicking on that row, we can see similar information. We have 200 gigabytes for the size, 3,000 minimum IOPS, 5,000 maximum IOPS, and our hypervisor snapshot reserve value, which happened to be the same as the hypervisor snapshot reserve value that we had in our compute offering. So all of this information looks very good. If we go over to the storage tab, we can see we now have root-11 and data-11, and they are both attached to our second VM, which is consistent with what we should expect to see. If we go over to our vSphere view, we can see that we do have a new virtual machine. And if we go take a look at our ESXi hosts, we can see now that both the host ending in .110 and the one ending in .109 have 4 connected targets. And to see some of these details, I'll right-click on our iSCSI software adapter, go to Properties, and then in Static Discovery, we can see our 4 connected targets. The one that's currently highlighted is the root disk of our first virtual machine. This one that's highlighted now is the data disk of our first virtual machine. The one that I've highlighted now is the root disk of our second virtual machine. And the final one is our data disk for our second virtual machine. Great, so all of this is as we would expect. I'll click on the Close button and switch back to the CloudStack GUI over to the Instances tab. And now this time I want to spin up another VM. I'll go to the Add Instance tab based on a template. And I'm going to actually select the original vSphere template. Now remember, mine is under the My Templates. We could use this one as well, but for this particular case, I'm just going to go back to the original one, which we already know about in our primary storage. Well, we actually know about both of these in our primary storage, so either one would work. What I'm demonstrating here is as we spin up this new virtual machine, we will see that we already have a copy of this particular template on primary storage, so we'll just go ahead and clone it from the SolidFire point of view, then issue commands to vSphere to resignature the UUID of the data store, and at that point we're able to very quickly spin up a virtual machine. We don't have to go through the process again of copying the OS template from secondary storage down to primary storage. So let me click on the Next button. I'll select that same compute offering. Next. I won't worry about a disk offering here. No affinity or networking changes. SSH is fine. Review, I'll just go ahead and stick in a name, VM-VS-3. and click on the Launch VM button. Now if I switch over to the SolidFire system here, in a moment we should see that we have a new volume cloned, and it's going to be placed in a volume access group. So here we are, root-12, and it is in our volume access group. So we're going to take this particular newly created SolidFire volume and talk to vSphere, have it resignature the unique identifier within the data store. And once that process is complete, and that takes a moment or so, we'll resume the video. Our VM has spun up, and I'm going to switch over to the Quick View column and click on View Console, log in, run FdiskL, and we see that we have a 2 GB root disk as expected. So this looks great. I'm going to exit out of here, and now I'd like to demonstrate the process of taking a virtual disk and switching its disk offering. So for example, we're in the storage tab now. I'll click on the vol-1 volume, and we can see here that we have certain performance expectations, 300 minimum IOPS and 600 maximum IOPS. We also have a 2 GB virtual disk. What we'd like to do is take this, and perhaps we're going to bump up the size to 4 GB, and maybe we want to increase the minimum and maximum IOPS as well. Let's go over to the Service Offerings tab. In Select Offerings, switch over to Disk Offerings and click on Add Disk Offering. We'll make SFDO2, and we'll give it some kind of a description that indicates how many IOPS to expect. Minimum, say 1,000, maximum 2,000. And let's just give it 4 GB. So we're going to go from 2 to 4. And the storage tag, we'll just need to make sure we target the storage tag of our primary storage of interest. In QoS type, I'll drop that down, select storage. For minimum, I'll put in 1,000, 2,000 for maximum, and we can have a different hypervisor snapshot reserve. Maybe we'll make it 200 instead of 125. So that's all we need here. I'll click on the OK button. And in a moment, now we have our new disk offering. Now let's switch back to the Storage tab, and we can take a look at our vol-1. I'll click on this name, and we can go over to the Resize button. And here we can select from our catalog of disk offerings. I just created this SFDO2, so let's use that one. And then we'll hit the OK button. If we switch over to vSphere, we can see there's some operations going on here, and they are complete. I'll switch back to CloudStack. If we scroll down a bit here, we can see that we now have a 4 GB virtual disk with 1,000 minimum IOPS and 2,000 maximum IOPS. If I go over to the SolidFire GUI, and here we can see I'll highlight the name of this volume. Now I haven't hit the refresh button yet, so what we would expect to see is 300, which I've highlighted, and 600 for min and max IOPS respectively. I'm going to go ahead and hit the refresh button, and we should expect to see 1,000 and 2,000 there. And I'll go ahead and highlight those. We do in fact see 1,000, which I've highlighted, and 2,000. Now, I'm going to come over to the size here. Before, this was 4.8 GB. It was the 2 GB virtual disk plus an additional 125% of that 2 GB, so 4.8 GB. Now we have a 4 gigabyte virtual disk with a 200% hypervisor snapshot reserve, so an additional 12 gigabytes. And yes, this does say 12.9 gigabytes. The difference is just in the reckoning of base 2 versus base 10 in terms of what constitutes a gigabyte. So that's why we see 12.9 here instead of 12. So this all looks good. If we go over to CloudStack now, over to our Instances tab, well, actually first, let me click on the Storage tab, and we can see for this particular row, it is this virtual data disk is attached to our first virtual machine. I'll click on the Instances tab, and here, again, because I don't have VMware tools installed, we won't immediately see this change in size in the virtual data disk until I either restart a certain process or just reboot the virtual machine. So what I'm going to do is reboot the virtual machine, and in a moment I'll come back and we can check out that new size for our data disk. Our virtual machine should be finished booting up. Let's go over to the Quick View column, click on View Console. I'll log in. I'm going to run FdiskL, and we can see our bottom device, our data disk, is in fact 4 gigabytes, which it was previously 2 gigabytes. So this all looks great. Thanks for watching this demo of our SolidFire and VMware integration into CloudStack, some of our additional features for the upcoming 4.11 release.